Good afternoon, algebra class. Today we'll be working with a direct variation, and direct variation is just an equation to a line, and direct meaning something that is straightforward. So we're talking about something being straightforward in language. But here's the equation to a direct variation, and you should be familiar with it. You probably have seen it. If not, we'll be working with it. And k in this problem is just going to be called the constant of variation. So it's a number. So k is always going to be some number that we're going to find. So what does it mean to be a direct variation? A direct variation is just one variable directly affects another by multiplying by a constant value. This constant value is k. So let's look at some examples. Oh, first of all, let's review what the function looks like. The form y equals kx. We do not want k to be 0. Okay, so we're always going to have to find what that k is. And here's an example of how we do that. So we're going to identify if this is a direct variation. In order for us to determine if this is, we need to be able to write it as y equals k times x. So solve for y. So if we take 4x plus 5y equals 0, we need to subtract 4x so that this goes away and we get 5y equals 0 minus 4x is negative 4x. The last thing we would do is if we would need to get rid of multiplying, so we divide. So we get y equals negative 4 over 5x. Don't divide. Leave this as a fraction. So k in this problem is negative 4 over 5. Negative 4 over 5. So this is a direct variation. So let's look at an example that is not a direct variation. So let's say I had 4x plus 5y equals 10. So in this situation, we would do exactly what we did before. We would subtract 4x. But this can't be subtracted. Okay? Cannot subtract. Not like terms. So we have to write it as 10 minus 4x. That's it. We can't subtract it. So 5y, we would divide by 5, and we would get y equals 10 minus 4x divided by 5. This is not a direct variation because there is no k in the problem. Okay? So anytime you have adding and subtracting in the problem, okay, subtraction cannot actually, add or subtraction cannot happen in a direct variation. Okay, so that's after you have solved for y. So when you go to solve for y, after solving for y, there can be no adding and subtracting in the problem. Okay, it has to be just multiplication. Let me go back to the definition. Remember, the definition says only multiplying. So that's why that was not a direct variation. So now let's work with an example that they're telling us it is a direct variation. So anytime they use these words, y varies directly, okay, this means that it is a direct variation. Okay, that means y equals kx. So in this situation, they're giving us that y equals 10 and x equals -2. And we need to find what the direct variation equation is. So we're going to try to find the k in the problem. So we substitute 10 in for y, because that's what they told us it was equal to. And we put -2 in for x, and we're going to solve for k. So we're going to divide by -2, okay? And we end up with k equals -5. So that's your equation. Y equals -5x. We can now use it to help find, when x equals -5, what we get for an answer. Or -15, I apologize. So -5 times -15 is going to give us 75. So when x equals -15, y equals 75. And that's your answer. Okay. The next problem is an application. Again, they're telling us y varies directly to x. So in this situation, the weight of the Earth is x. So down here, this is x, and the weight of the moon is y. So what we're going to do is try to find the k using the problems or the numbers up here. So if we know that 100 is going to be the x and k, or let me rewrite that. We know that 16 is our y and 100 is our x. We can actually divide by 100 to find our k. If we take 16 divided by 100, we get 0.16. So k equal, oh, I'm going to have to change that. And that was equal to 16.6. So if we divide 16.6 divided by 100, we get k equals 0.166 rounded. We get k equals 0.17. So we're going to have our formula 0.17x. 0.17x is the k that we're going to use down here. So I'm going to take this out and put in 0.17. So we're going to go through and fill in this table. When x is 0, we get 0. So we're going to graph this. So we get 0 down here, 0, 0. Okay. All direct variations go through the origin. Okay, so that's always going to be true. So for x equals 25, 0.17 times 25 is going to be 4.25. So we're going to go down here to x equals 25, which is here, and go up to 4.25, which is right about there. Now x equals 50. Oops. We're going to get 8.5. So 0.17 times 50 is 8.5. So 50 and 8.5, be right about there. 100 is going to give us 17. So 117, that'll be 16, 17 will be right in the middle. And then 125 is going to give us 21.25. 0.17. So 125 is about what did we say, 21.25, so we're about in there. So we should see that these all fall close to the same line. So the direct variation forms a line, and that line is formed by finding the y's associated with x's that will either be given to you or you can make them up on your own. So that's direct variation. We'll go over some problems in class as well. Prepare your notes for class and answer the questions after the video.